In this video, we're going to talk about Heron's formula, and it is a formula that is used to find the area of a triangle. Okay, and we have seen, area formulas before. We of course have the classic 1/2 base times height for a triangle, 1/2 base times height for a triangle. We also have the area formula 1/2 AB. Let's see, well, AB sine C. So take two sides and the sine of the included angle times 1/2, and that's the same as our area. We've seen that, and we'll talk about law of sines eventually, but that actually is a very nice result of the law of sines. But maybe, just because we don't have enough area formulas, we're going to throw a third one in there called Heron's formula. And this is actually really useful if you have a non-right triangle and you know all the sides. And we'll see why as we talk more about the area formula. Now, I'm not going to go through and give the proof because it is an algebraic time. It takes a lot of energy and effort to develop this formula. So if you're interested, go ahead and Google Heron's formula proof and have fun reading it for a half hour. Okay. We'll just use the result. Okay. And it says that area is the square root of, and to be clear, these are all multiplication signs in here, this S minus the quantity S minus A times S minus B times S minus C. Okay. And this S thing that we talk about, it's the semi-perimeter. So when we talk about, we know what perimeter is, we add up all the side lengths, right? And then semi is just half of that. Okay. So take half of the perimeter and then put it in this calculation. Okay. So we want to just do a little example with this just so we're kind of okay with this calculation. Okay, so this is find the area of the triangle ABC with B, A, and C given. Now I'm going to sketch it out, and then as I sketch it out, you're like, oh, we just saw this triangle in a video, and I'm going to be like, yes, we just did. Okay, but let's just do B. Try again. A, B, C, and then we have 61 degrees and 28 and 19. Okay, so our first task is, of course, to find C. Okay, and then we did C squared is equal to A squared plus B squared minus 2AB cosine C. And we went through and showed that this was 25.1. Okay, so in some cases, yep, you're given sparse data about the triangle and you need to finish the triangle. And the reason I can stop at C, I don't actually need the angles, is because to find the area, right, I'm being asked to find the area. Area is the semi-perimeter times the semi-perimeter minus a side length times semi-perimeter minus another side length and times the semi-perimeter minus the third side length. Okay, so I just need to be able to calculate the semi-perimeter, which requires me to know all the sides. Okay, so let's get this calculation for S. S is going to be 19 plus 28 plus 25.1. Take that whole thing and divide it by 2. Okay, if you do this, I get 36.05 precisely. Okay, and so then when I do my area calculation, okay, so I'm going to do square root, and this, it's kind of annoying to write out, but it builds character. That's what I was telling myself. 36.05 minus, say, 28. 36.05 minus, so length B is 25.1. And then 36.05 minus 19. Okay, so now if I was putting this in my calculation, I would worry about the square root last, and I would just do the stuff underneath first, and then do the square root. But if you do that, I get my answer as approximately 232.8 units squared. Okay, I don't know what units we're in, but I just always include the label of units squared. Okay, if the units aren't specified, just so I know area, I'm recognizing that the units are square units, so there we go. Okay, so Heron's formula, it seems a little bit more intense than doing our other area formulas of 1/2 base times height or 1/2 AB sine C, probably, but it does have the benefit of, if you are in the context where you know all the side lengths of a triangle, great. Just use those side lengths to find the semi-perimeter and then do the calculation with the semi-perimeter to get the area.